Hi, this is Alex from devstories.eu. LiteLLM, the Universal LLM Gateway, Episode 8 of 24. When your primary language model provider suffers an outage, does your application go down with it, or does it silently pivot to a backup? Today we cover API outages and fallbacks, the exact mechanism that keeps your system online when external endpoints fail. First, it helps to distinguish this from a related concept. Fallbacks are not load balancing. Load balancing proactively distributes your traffic across multiple active deployments to prevent overwhelming any single endpoint. Fallbacks, on the other hand, are strictly reactive rescues. They sit idle during normal operation and only engage after a definitive failure has occurred. The primary goal is maintaining high uptime, ideally hitting that 99.9% mark, even when your upstream providers do not. External APIs will inevitably throw 500 internal server errors or 429 rate limit exceptions. When that happens, a fallback configuration tells the proxy to intercept the error mid-flight and route the request to an alternative provider, completely shielding your application code from the disruption. You set this up in your proxy configuration YAML file using a fallbacks array. Consider a concrete scenario. Your primary deployment is GPT-4. You want to ensure that if GPT-4 goes offline, the proxy will automatically try Claude 3 Opus instead. In your configuration file, you define your GPT-4 model setup as usual. Inside that specific model definition, you add a fallbacks key. The value of this key is simply an array of strings where each string is the name of another model defined in your configuration. You add Claude 3 Opus to this array. When your application sends a prompt to the proxy requesting GPT-4, LiteLLM routes it to the primary endpoint. If that endpoint returns an error, the proxy logic catches it. If you have retries configured, it might try the primary endpoint a few more times, but once the primary definitively fails, the proxy triggers the fallback sequence. This is where it gets interesting. The proxy takes the exact original prompt and parameters. Because LiteLLM normalizes the API format, it seamlessly translates the OpenAI formatted request into the Anthropic format required by Claude. It immediately sends the translated request to the backup endpoint. Your application code does not need to handle any error logic, rewrite the prompt, or manage API keys for the second provider. The proxy handles the entire pivot internally. You are not limited to a single backup. The fallbacks array accepts a list of models. If your primary GPT-4 fails and then your first fallback Claude 3 Opus also fails, the proxy moves to the next name in the array. It steps through the list sequentially. If it reaches the end of the array and every single backup model fails, only then does the proxy return an error back to your application client. Here is the key insight. By layering diverse fallback models in your configuration, you effectively isolate your application code from external instability, transforming hard provider outages into nothing more than invisible latency spikes for your end users. Thanks for listening. Happy coding, everyone.